Hello again. So in this second video, we're going to have a look at correlation in a slightly different way. We're going to have a look at the strength of a correlation. So if you look at the pictures in front of you right now on the screen, you've got 5 different scatter graphs, and this is what you've been, I suppose, used to seeing. You have over on the left here what we would call a perfect negative correlation, where all of the data points actually lie exactly on the regression line. Over here, you've got a slightly less perfect negative correlation, where all of the data points are slightly spread out around the line of best fit, the regression line. We've got a no correlation in the middle, we've got a positive correlation, and then we've got this perfect positive correlation over on the right-hand side here. And what we have down here is this letter R. Now, R stands for the product moment correlation coefficient, or the PMCC for short. Now, the PMCC is just a measure of the strength of a correlation, and you can see over here when it's a perfect negative correlation, we say that R is -1. Perfect positive, R equals 1. And so correlation coefficients do just lie on this scale, okay, from -1 up to 1, and with 0 correlation exactly in the middle, in between. The closer we get to 1, the stronger the positive correlation. The closer we get to -1, the stronger the negative correlation. I should point out at this stage that R is the letter that's used for the PMCC. And we typically use R when we're dealing with a sample of some data. What we have for a population is the Greek letter rho. And that's a population correlation coefficient. And that's important simply because we're going to do some hypothesis testing in a minute. And we need to know when to use R and when to use rho. But they both mean the same thing. So here are a set of data. We've got from the large data set, the daily mean wind speed and the daily maximum gust. Now, the large data set is something that we're going to look in more detail at soon enough. It's something you need to be able to engage with. It's something you need to know some information about. For example, you would need to know that the wind speed is measured in knots and the maximum gust is measured in knots, and just things like that. You've got to familiarize yourself with the data set, and I will help you to do that with some activities and lessons. But for now, we've just got this table of data. Now, as you can see, it's bivariate data, by which we mean we have 2 different variables, and we could plot this information into a scatter graph. But rather than plot the scatter graph, we're just going to input some numbers into our calculators and work out a value for the product moment correlation coefficient, and therefore draw some conclusions from that. And we'll also have a look at how to write down your regression line equation. Although it's not asked of us, we may be asked of it. So here goes. First thing we should know about this table is that we have 2 days of the month, the 8th and the 9th, that have no data for the maximum gust. Now that means we leave them out. We don't use them. We don't have enough information to use them, so we forget that they're even in there. Okay, so any correlation that we test, anything we do, is going to leave those values out. That's why it was written as NA, not applicable. Second thing we're going to do depends on your calculator. So if you have the ClassWiz, what you're going to do is menu 6. Okay, so if you're in your normal calculation screen, you press menu 6 for statistics, and then you go to option 2. So menu 6, and then option 2, which is called y equals a plus bx, because that's what we're working with. And then you have the opportunity to enter the data into a table. You should see 3 columns, x, y, and frequency. You enter the data, and your x column will be the wind speed, your y column will be the gust, and your frequency is just going to be empty. If you don't have the frequency column, don't worry, because we don't need to use it anyway. So if you put the data in as that says, what you should find afterwards, if I do it along with you, we've got 4, 4, 8, 7, 12, 12, 3, and 10. Remember, we're leaving out those two columns that we didn't have data for. And then we've got 13, so this is the Y column now, 13, 12, 19, 23, 33, 37, 10, and 23. And once we've entered all that, we need to go to option. And when we're in option, we need to go for option number 4, which is the regression calculation. And you'll have 3 values. You'll be given A, you'll be given B, and you'll be given R. And what you should see there is that A is 1.85 to 3 sig figs, B is 2.59 to 3 sig figs, and R is 0.95. Sorry, 0.953 to 3 sig figs. Now that means we could write out our regression equation if we were asked. We could have y equals a plus bx. That's how we begin. In this case, the y, the dependent variable, is the gust. So we have g equals 1.85 plus b, 2.59. And that's lots of the wind speed. Okay, so that's our regression equation. What we also have is our value for the PMCC. So R equals 0.953. Now 0.953 is pretty close to 1, so we would say that there is a strong positive correlation. And if we were asked to interpret that strong positive correlation, we would say that as the wind speed increased, the gust increased. Now, that's for the class whiz. If you've got a class whiz and you've got all those values and you know exactly what you're doing, then you can skip ahead a little bit. I'm going to talk through how to get it on the CG50 because it's slightly less clear on the CG50. So when you're in the calculation screen on the CG50, you need to go to menu 2, which is your statistics, and you'll have the table in front of you as well. So you've got probably 4 columns there. You just need to use the first 2 columns to enter your data. Okay, so we'll say menu 2. Once you've entered the data, you actually need to then press F1. So we'll enter data, then we press F1, which says graph. Apologies for my handwriting here. Now once we've pressed graph, you press F1 again for graph 1. Now what that will do is it plots the scatter graph for you. So you'll be able to see the scatter graph in front of you, and I'll let you play around with what the cursor keys do on the direction pad and what the other things do. But in order to get this information, the A, the B, and the R value, you need to press F1 again, which says calc. And then you need to press F2, which just says X. Then, told you it was slightly more complicated on the CG50. F2 again, where it says A plus B X. And then you're given all the information. So you've got the same values you should see for A, for B, and for R. You're also given R squared, and you're also given MSE, neither of which are relevant to what we're doing. So you can also come up with the regression line like this, and you've also got the value of R, which you can then draw a conclusion from. So you will get practice at that because we're going to practice it in lessons at the end of next week. but it's worth doing now, which is why I have a question for you. So pause the video, work on the question, then start the video to see the answers. And welcome back. So here we have it. If you input that information into your calculator, which is the way that we get the PMCC, you should come out with R equals 0.835. Now that 0.835 is fairly close to 1 again, so we have a pretty strong positive correlation. And then part B, you may or may not have answered that, but it says comment on the suitability of a linear regression model. Now, because the correlation is pretty strong, a linear regression model seems to fit it quite well. And so we can just say that the linear regression model is suitable, okay? And that's because R is quite close to 1. Now, what we're going to get into in the next video is what happens when data cannot be or should not be modeled using a linear regression model. And that's when we have a slightly lower correlation, or what appears to be not very much correlation at all. And we'll get into it in the next video, like I said, but we end up using a logarithmic model to draw basically the line of best fit. So we have a logarithmic regression model. Okay, so that's the kind of easy stuff, I suppose. The next thing then is about hypothesis testing. Now, we've studied hypothesis testing in the binomial distribution very recently, and this is similar. Not identical, but it's similar. And I'll let you read the question. So temperature and rainfall for 15 days suggest a null and alternate hypothesis for a two-tailed test to investigate if there's a correlation. Now, the great thing about hypothesis testing for correlation is it's actually pretty straightforward in the end. We still have to, just like binomial distribution, we still have to state our hypotheses. We're still going to have an H0 and we're still going to have an H1. Now, if you remember, the H0 was the null hypothesis. It's the nothing to see here, everything's fine. And in this context, there's no relationship between temperature and rainfall. Now, here's where the distinction between rho and R comes in. Because what we're doing here is we're making a generalized statement about the population having examined a sample. So we will be calculating an R value. In this case, it's given to us, but you may be asked to calculate it based on a sample for the data. And from that sample value, we're making a conclusion about the population. So for our hypotheses, you need to write rho. And for our null hypothesis, it's that rho equals 0. There's nothing to see here. Everything is the status quo. Nothing is correlated. So the H0 in a correlation hypothesis test is always that there's no correlation. The H1, well, just like binomial distribution, it can be phrased in the question. You're looking for values saying it could be positive, it could be negative, it could have 0. This is basically telling us to use a two-tailed test, and so we're saying that rho is not equal to 0. And make sure your rows look sufficiently different from your lowercase p, because the lowercase p is obviously what we use in the binomial distribution. Now, that's a null and alternate hypothesis for a two-tailed test. That's part A of the question. Done. 2 marks. Fantastic. We're given this R value. Okay, R is 0.37. It's not very close to 1. In fact, it's closer to 0. So again, we've got that kind of subjective aspect coming into it. You know, I might decide that that's not very close to 0, actually, but you might decide that it is. And so what we need is a threshold beyond which something is significant or something is not significant. And again, that's very similar to the binomial hypothesis test. Okay. Now, for the PMCC hypothesis test, you will need a table of values. This is in your yellow formula sheet. It's given to you in the formula book, and it is right here at the bottom of the page. And what you have in this page This is the side we're interested in. We're not interested in the right-hand side. So the product moment coefficient. We have a sample size, which is given to us. And in our case, 15 days is our sample. So 15 is the value we're interested in. So down here, there's our 15. That's what we're interested in. We're testing our hypotheses at the 10% significance level. So over here, underneath level, are our percentages. Okay, they're written as decimals. So the 10% significance level is this one here. Now, all we need to do now is look at where this row and this column meet. And it's this value here. Now, what this value is as follows, and I'll demonstrate it using a line again. We have -1 for perfect negative, we have 1 for perfect positive, we have 0 for zero correlation at all. And what we're looking for here is, for something to be statistically significant, it would have to be stronger than 0.3507 in this direction, or it would have to be smaller than negative 0.357 in this direction. So you need to compare your value of R with the value from the table. If it's a positive correlation, then it will be bigger than 0.3507. If it's a negative correlation, it will be smaller than negative 0.3507. These are all positive values, but if we're testing for negative correlations, we just put a negative in front of the number. So we can say that our value of R, 0.37, is greater than 0.3507. And so, just like any other hypothesis test, we write two conclusions. We say that there is evidence of a positive correlation, and it's between the temperature and rainfall. And then the second statement is contextual. And so we basically saying, thinking about which one was our dependent variable and which one was our independent variable. And we would say evidence of more rainfall at higher temperatures. And we're done. So just a quick recap. Hypothesis testing, your null hypothesis is always that rho equals 0. Your alternate hypothesis could be two-tailed, in which case it will be not equal to 0. Or it could be one-tailed, where you'll be testing for a positive correlation on one side, or a negative correlation on the other side, in which case you would be using either rho is greater than 0 or rho is less than 0. You would then, if not given, calculate your value for the PMCC using your calculator. Then you use the tables. Look for your sample size, look for your significance level, and then you compare your R value with that significance level. If you're testing for a negative correlation, chuck a negative on the number. Once you've compared it, you write your statement. And remember, be non-committal with your statement. You just say that there's evidence of correlation or there's no evidence of correlation. You don't commit to saying there's definitely correlation. All right, over to you. This time I'll put two questions, and all I want you to do is answer them by pausing the video first, and I'll share the answers with you shortly. Okay, I hope you paused the video there so you could answer the questions. And here are the two sets of work solutions. So pause the video, check your answers, and make sure you got them all correct. And then when you come into lessons next week, this is our starting point, and we'll get going. There's one more video to come that's on nonlinear data. I will endeavor to upload that tomorrow rather than today. See you soon.